Alright, so today we have longest substring without repeating characters. This is LeetCode number 3. So this is a pretty popular problem, one of the original LeetCode problems. And it's really popular because it's kind of a bare bones introduction to the two pointers method, which is something that is used in a lot of array problems uh, or string problems like this. So if you'll see something like substring, you should probably think two pointers approach. So let's dive into this problem. So given a string s, find the length of the longest substring without duplicate characters. So when we see without duplicate characters, the first thing we're saying longest substring without duplicate characters. No duplicates immediately means set, is what comes to mind for me. Besides that, what is a substring? A substring is a contiguous non-empty sequence of characters within a string. So the big parts of that is highlighted with the non-empty. So a substring cannot be empty, so it can't be an empty string. And as well as that, contiguous. So contiguous means it needs to be continuing without any gaps. So like an array is a contiguous spot in memory. And here's an example. If we look at example 1 here, we have ABC, ABC, BB. If we're looking and we look at A, that's a substring. AB is a substring. ABC is a substring. All of these are substrings. CA, CAB, CABC, these are substrings. What wouldn't be a substring is an empty string, and as well as, say, we had A, and then it skipped to C. So skip B. See, there's a gap in between. That wouldn't be a substring because it's not contiguous. So that's what that means. It means it needs to be contiguous, continuing between. There's no gaps. This actually, if there was a gap and it was A and then C, that would be known as a subsequence. But we're looking for a substring here, and we're looking for the longest one without duplicate characters. So let's look at example 1 and try to find what the longest substring would be. So we have A, B, C. That's no repeating characters, so that's 3 so far. Then we encounter A, so that's a repeating character. Okay, so we know our longest so far is ABC. Okay, so we need to get rid of one of the A's because that is what our duplicate is. If we're wanting to continue through the string, we can't really remove this one and then go to B because then it would be a subsequence. It wouldn't be a substring, right? So we need to remove this A. And what I mean is, if we remove this A and then we move forward to B, then we'll have A, B, C, B, but we'll have this gap between C and B. And we can't have that in a substring. So we have to remove this A. So we remove this A, now we have BCA. Okay, it's 3, and it's valid. We move forward, we look at B. B, well, we already have a B. So we do the same thing we did earlier. Can't remove this B because we need to move forward. We remove this B. Now we're looking at CAB. Okay, valid. 3, again, longest length. Alright, we move forward, we see C, yet again. Remove this left C. Continue. ABC, again, valid. 3. Move forward, B. Well, we already have a B. Okay, so now we have A, B, C, B. So we need to remove this left B, but it's not the first one in the thing, so we actually have to remove A first so we can remove B. So we remove A, then we remove B, and now we're looking at CB, so we're valid again. Okay, we move forward, we see B, not valid. We'll have to do the same thing we did earlier where we remove the one before it so we can actually remove it. That way we're not in a subsequence, we're in a substring. So we remove C and B. Now we just see B. So they're the longest. We had a few that were length of 3. The first length of 3 is at ABC. That's the answer. Answer is ABC with length of 3. So that's how that works. Example 2, they're all just the same character, so it's going to be 1. Example 3, we'll look at this one. Alright, so PW, length of 2, we see another W. So now we need to get rid of one of the W's. Has to be the left one. Get rid of this one, get rid of this one. So now we're back at length 1. Total length that we've found so far that's the longest is 2. Now we go from W to K. That's 2. Valid. WKE, that's 3. So no longest, and it's valid. WKEW, not valid. Get rid of the W. KEW, valid. 3. First one we encountered was WKE. That's our answer. With length of 3. Right, and then here's an example, kind of like I was mentioning earlier. Notice that the answer must be a substring. PWKE is a subsequence and not a substring. So PWKE. So that would be valid here if we were looking for a subsequence. But since we're looking for a substring, we can't just get rid of one of these because there would be a gap. Okay, so let's talk about how we actually, what's our intuition? How do we solve this problem? Well, going through it just with our eyes, I feel like we kind of thought of a decent way. And like I mentioned with that two pointers approach, so it looked like we were moving forward, and then whenever we encountered a duplicate, we moved the left pointer forward. So I think that's what we're gonna do. So let me write that out. And actually, um, I'll say two pointers left and right. Right always moving forward. Left moves forward once we encounter a duplicate until we no longer have a duplicate. Okay, so that's good. So how do we know we have a duplicate? We need a way to store what characters we visited so far. And I think a good way to do that would be a hash map. So store characters visited in a hash map. And I say hash map because we can store the character as well as its frequency in a hash map because we have key value pairs, right? Okay, so we know now we have stored our characters and their occurrence rate. We have two pointers, so we're moving through our array, and we have our condition to ensure we have no duplicates. The only thing that we have left is to actually find the length of the longest substring. So we need to store max substring we've seen into a integer variable. Okay. So I think that's pretty good. So to do that, we'll do left, like we were talking about, is equal to 0, and then we'll do, we can do a right here if we wanted, and then max equals 0. And then we also need our map, so let's not forget about the map. So I'll put that up here as well. Map and character, and then the frequency rate. It's a new hash map. And then we do a for loop for int. So we already declared right, so actually not int I, but we'll call this right. Declare its value at 0. Right is less than s.length. And remember that when we have strings, this is actually a function. It's not just length as if it were like an array. So, and then we'll do right plus plus. Okay, so now we have our basis set up to iterate right through each value. So what do we need to do? We need to add our value onto our map. So map.put, and actually we'll just we'll do like this. So instead of typing it out, in case we need to type it out multiple times, we can just do R here, and this is s.char@. So when you have a string, you use the char@ method to find values at their indices, which we have. And the first one would be 0 indexed character that is in S. You can't just do S sub 0 when it comes to a string. You have to use char at. Unless you did S, you can also do .s.toChar array. You know, we did that, and then we could do that, but we'd have to just more overhead to create it into an array. We don't need to necessarily do that, but it is a feasibility. So back to the subject here. First thing we're going to do is put in this map right, which we've encountered, and then we want to put the frequency of right. So to get the frequency, we'll do a get or default r and then 0 plus 1. And the reason we're doing a get here because we want to get the value that's associated with the key in case it already exists. And the reason we do an or default because if it does not exist, then if we just did r, we would get an error because it doesn't exist. So we default to 0 and then we add 1 each time. So if it doesn't exist, puts a 0 in, adds 1. If it does exist, grabs the value that does exist, say it's 1, adds 1, and makes it 2. So we put our values into our map. So now we need to check if we've encountered a duplicate after we put right in. So let's say that we're back on our input example 1 over here. We've moved right forward, and then we find A, so we know it's a duplicate. So remember earlier we had A, and then say we're at C and we moved to A again. Then we had to move the left pointer up to B to get rid of that duplicate. So while map.get r is greater than 1, so while the value that we're looking at A on the right side is greater than 1, we have to move left forward until it's not anymore. So just like we did earlier, we'll do char at left this time. Then we'll do map.put L and then map.get L minus 1. So we're subtracting one value from L, and then if we need to check that if it's empty now, map.get L equal to 0, and we remove it. So this is finally when we actually do our removal, and we'll do left plus plus. Okay, that looks good to me. So the only thing that we have left now is to store the substring that we've seen so far. So in this for loop so far, we've handled adding the value that we're looking at as we go forward onto our map of things that we've seen. And we've also handled, if we see a duplicate, moving our left forward until we remove it. So that looks promising as well. So the only thing that we have left on each iteration of right, every time that we're moving forward, is we need to evaluate the current substring of left to right that we're looking at, and whether or not it is the largest that we've seen. So we can do max equals, and we'll do a math method here, max, and this just takes 2 input parameters, and it will return the larger one, the max one. So we'll re-put max in there, and we'll compare max against right minus left plus 1. And we do right minus left plus 1 because we have our right and our left, and we want to see the length of that window that we have. So this length in between these two is our length of our substring. And the reason we do a plus 1 is because if we start at 0 and both are at 0, well, there's actually a value at 0. Say for the input we're looking at A, well, A exists, and that is 1. So when we're doing a 0 indexed array, we want to add 1 to the value at the end, just to account for that, be inclusive. So only thing left now is to return max. I think that this should work, so let's submit it and see how we did. All right, so accepted. So that is longest substring without repeating characters. Only other thing I will say is we're looking at time and space complexity. So we have a for loop, and this is gonna iterate through every character within S. So that's going to be O of n, time complexity, where n is the length of the characters in S. And then we also have space complexity here of O of n because we are creating a new map. Typically, typically when you have a two pointers problem, if you didn't have to like store the characters that we had visited, you would have a O of n time complexity and a O of 1 linear space. But since we have to visit the like store the visited characters, we'll have O of n space complexity here as well. And now this is technically in a worst case scenario when we go through the while loop. If every single time everything's a duplicate, like in B, then we're visiting and removing and visiting and removing and visiting and removing. We could have in a worst case 2n, but when you boil that down, it goes back to n anyways for interview purposes. So, all right. That was longest substring without repeating characters. Take care.